All right. Oops. Just a minute. Okay, let me. Made a mistake. PowerPoint. All right, all right. And today I'm starting my explanation from the next one, the related fields of studies. Yeah? The very important portion of today's archaeology study is the scientific analysis. As I mentioned before, we saw this tremendous development of science technology, analysis technology from the 20th century. And thanks to that, we are able to get more and more information from the sites, especially those minute, very tiny, small segments, elements included in the soil, which is invisible, very too small to see. You can't really see it, but so many things can be found and analyzed through this scientific technology. And they would give you all sorts of information. And not only invisible ones, of course, but many various fields of science would help you adding up those data from the sites. Like I've shown here the keywords: animal, plants, would be bones and shells. Well, animal itself very hard to find. Organic material it decays so easily. So unless it's frozen, like in Siberia, or the one I showed you last week, waterlogged site. And 水に使ったね、低地の遺跡ね、waterlogged site, you would find something organic material, real, in reality, I should say. And let me see. Okay. Oops. Just a sec. Okay. This picture shows you the long one is a trunk of an elephant, elephant tusk. 牙ですね、象の牙。And the upper one is antler. It's 鹿の角ですね。And these belong to the layer of about over 20,000 years. It's in the Paleolithic time, 旧石器時代ですね。And these are found from the bottom of a lake in Nagano Prefecture, the middle of Japan. And it's a highland mountain area. And this lake is called Nojiri Lake. It's really related to ICU too. ICU always, every year in summertime, they would put up a camp right there with a collaboration with the YMCA. And so every ICU students would know the name, but it's really also famous for drying out in the wintertime. It's so high in altitude, and in summertime it has a water supply, so you have a lot of water in the lake, so it's the lake. But in wintertime you will lose the water, and part of the bottom of the lake would be exposed like this, dried out. And one time, maybe 50, 60 years ago, one of the inhabitants by the lake was watching at the lake in the wintertime, and at the bottom, dried bottom, he found some strange things, not the rocks, but it has a certain form and pattern on it. And he picked it up and was very heavy, like a stone, but he couldn't tell. So he brought it to university, Shinshu University, and went to one of the paleontologists, 古生物学者ね, paleontologist. And the professor told him that it's a tooth of an elephant. And he was surprised, the elephant, you know. Then all the specialists came down and made investigation and found out that they were used to be elephants around this area. They found a lot of bones and teeth and tusks and, you know, all the parts, including other animal like big deer, bighorn deer, オオツノシカって言うんですけどね。Bighorn deer, which is a huge deer. So like monster, you know. And elephants are also big, you know. The particular species called Naumann's elephants were present at the time all over Japan. And later on, they found mammoth remain in Hokkaido, Northern Island. And down to Hokkaido, they had mammoth and other elephants. But in Honshu, main islands, we haven't found any mammoth. But this Naumann's elephant, Naumanzo, and this was the first case. And well, they call it moon and star because it looks like a moon, crescent moon and star. So the story became spread. I mean, the story spread all over and it became so famous. And they invited all the kids and normal people to excavate these in the wintertime every year. So for what, several decades they've done that and found out so much of these remains. You know, they remained for what, over 20,000 years because they were underwater, right? The water, clear water, fresh water, kept them in shape. And so even though we may find some animal remains, you know, we need the help of the specialists, zoologists and paleontologists and stuff like that in many cases. And so you may find bones, shell. Of course, shell is very hard to deteriorate because it's consolidated in calcium. So we often find shell mounds and as a remain of Jomon people activities. And sometimes wood, if it's preserved well, and seeds of plants, and DNA too. And these data, if we were able to find those, you know, very good samples for reconstruction of resources, you know, what kind of resources they've used in that time. And wood and seeds may remain underwater too, but once they were burnt and not burnt perfectly, and turns into charcoal, 炭ですね, charcoal, then it would remain for a long, long time too. Charcoal is a very, very solid material. And it would stay in the soil like thousands and tens of thousands of years. In the Paleolithic sites we're excavating, we sometimes find concentration of speckles of charcoals, tiny, tiny charcoals concentrated in a certain area, like 1 meter diameter. And immediately we would know that ancient people built fire there, you know. So charcoals are very good, give you good samples too. And charred seeds would remain in form in many cases. So you still, it's been changed, quality is changed, but you can see the shape and you would be able to determine what kind of seeds they are, and so on. And so you will be able to know the resources that they used, partly though, you know. And by compiling all these data, you will be able to build up something like this. Did I show you this before? It's called Jomon calendar. And in Jomon time, when they had this warm and nice weather and clear 4 seasons, not too cold in winter, not too hot in summer, and they have this circulate life cycles, you know, in a sense, of various food resources, plants and animal, you know. Springtime is a springing time, you know, all the buds coming out, and to the summer, you will get a lot of marine resources, fish, and in northern part they would use a lot of sea ocean mammals, 海生哺乳類ですね, like seals and stuff. And also that's a shell time. Shell would grow bigger in that time. And towards the autumn, you will get this salmon coming back to your river, and all the nuts and fruits. This is a high time for this harvest, right? In winter time, you would go hunting. I think I've shown you this, shown this in the last lecture, no? I don't remember. Winter is a high time for hunting because it's cold for animal too. They would not be able to put on clothes. So instead, they would add up fat more than other season. So if you hunt the animal in wintertime, you get more fat. That's nutritious. You know? You want more fat. And at the same time, you would get better quality of fur. The fur becomes thick and dense. And the high quality of fur would be able to obtain in wintertime. So it's the high season for hunting. Like that. This kind of Jomon calendar could be created by all sorts of minute proofs, minute elements or evidences from the sites. And most of them were clarified through this scientific technology, analysis technology. And even smaller one, DNA. DNA is quite a rage now. And we use a lot of DNA analysis, as you can tell. And this is one of the example. And these are the DNA patterns of the chestnuts found in a site up in northern part of Japan called Sannai Maruyama Iseki. It's a famous site. It's a big site of Middle Jomon period, a huge settlement. And we call them department store of Jomon culture because they've found so much variety of artifacts and, you know, stuffs that you'll be able to see all over. I mean, it's like a compilation. It's a pileup of various artifacts from all over Japan, you know. So it's like a department store or convenience store or whatever you would call. So, and also they had this waterlogged area. 水に浸かったところがあってね. And they found this basket, real basket filled with this chestnuts. And they've analyzed the DNA of chestnuts. And they concluded that, this upper part, these single column represents each speckle of chestnuts, and DNA patterns are almost the same. So they concluded that these Jomon people at this site formed a forest, chestnuts forest, intentionally. They grew the chestnut tree and they increased the number of tree and grew the maintains the forest, chestnuts forest intentionally. That's their conclusion. Down below, these are the different chestnuts from different part of the area. So, you know, the patterns are scattered like this, you see? So, and that's their theory from the DNA analysis data. But don't you think that theory is kind of strange? Anybody felt something strange about the theory? Or about building a forest, making a forest? You know, this is very important. In archaeological study, you really have to use your imagination too. Not only evidences, but to explain and make story using the evidences. You really need the reality and imagination. And I want you to imagine how you would collect chestnuts if you were Jomon people. No, you don't have to be a Jomon people, but you may go down to the chestnut, under the chestnut tree even today, or other nuts, whatever. And you have a basket, you're trying to collect the fruits, nuts. Well, how do you collect them? Imagine, just imagine as a reality. Would you pick up one piece of chestnuts and put it in a basket and move to the next tree and pick up another piece of chestnuts and move to the other tree? Would you do that?
I mean, obviously you go to one tree and then you get as many as you can to put in your basket.
Right. Everybody would do that, right? Yeah, I would do that too. But that's the activity pattern represented by this theory, because each single chestnut would represent each different tree, right? If so, then this theory is correct. You know, all the tree has same DNA pattern, right? But you wouldn't do that. That's an idiot, you know. You would just collect as many as you said right now, and then move to the another tree, right? So that means the compiled chestnuts in the basket they found excavated from that site would represent that they were found from one tree, under one tree. It's possible, I mean, it's more possible that they would collect that under one tree if it's in the cluster, in the basket, right? Then it's natural. It's taken for granted that all the chestnuts would show the same DNA pattern. You see, that's like a trap pit of science. You would leave, you would, you know, put so much faith in scientific technology, the highest modern, latest technology. It's good. They will give you a lot of data. They will help you a lot. But you really have to think, you really have to be careful when you use the data and try to explain something. You are very easy to make mistake by misusing those data. Okay, so this is one example. And of course, we do now believe that the Jomon people, some of the Jomon people could have grew so many trees, like chestnut trees, to grow up a forest, make a forest, but for other reasons, of course, like a pollen analysis and stuff, but not from this data, not from this. This is different data. Okay. All right, and as I mentioned right now, another data, important data from the plant resources are pollen, 花粉ですね。And pollen may sound really soft, but they are not. They're the tiny pieces of pollen is covered with very rigid shell. So pollens, most of the pollens are very solid and very hard to decay, very hard to disintegrate. So they will stay in the soil, even though they're too small to see, invisible. But if you can extract pollens from the soil of each layer, you would be able to tell what kind of plants were growing in that layer time, right? So nowadays, it's really, really important to look for these soil pollens. So we always take soil samples, not only artifacts and features, but we always take the soil samples, various soil samples to detect this environment of that time. And as you can see, the forms of the pollen are so different, depends on the species. And this is one of the famous one of a plant opal. Oh, wait a minute. Yeah, so the plant specialists, they would all know which kind of species each form of pollen would belong to. So they have all the samples. So if they can find out any kind of pollen from the soil sample, then they would be able to say, oh, this area is forest now, but it used to be a grassland, open land, or something like that, you know? It's very, very important elements to tell you what kind of environment it was. And another type of stuff is opal, plant opal. Opal is like a glassy material. And some of the plants have characteristics to build up certain glassy material inside their body, inside their leaves especially. And like rice has this slender, long leaves, and they would build up this kind of particles, glassy particles inside. And the rice species always bear this particular shape of the opal. So whenever you find these from the soil, you would be able to tell that they used to be growing rice right there, you see? And since they're glassy, and it's like a mineral, so like a stone, so they would not decay out in a short time. So it's very easy to find out. And depends on the species and the subspecies, you would see different forms of this opal. So it's very easy to tell the differences. And another thing is a diatom. Diatom is a plant that normally lives in water. Like an algae, tiny algae type of plants. 藻ですね。藻。水の中に入る藻ですね。And diatom also build up glassy formation in their body. And it's like their bones, you know, their body, frame of the body. And each species showed totally different forms. So it's very easy to distinguish one from another. And there are types, several types, salt water. These are the guys who wants the salt water, and fresh water, lake, and even fresher river, flowing river water. And some guys are very strange, and they like to be in a dry area, not in the water. So from detecting these diatoms, you would be able to find the water environment of that area. It could be like you would say this area is dry now, but it used to be a lake or a marsh, pond, whatever. And for example, wait. Just a minute. Okay. Right. I'll show you one example. There's a castle all over, but in Japan too. And from medieval period, those lords and local lords would build their own castle. And they normally build it on the mountain top or hilltop, the high place. It's very good for protection. It's good to be in high points. It's very hard to attack from the lower area. It's very easy to attack from the top down. So they built the castle high, raised castle, and they also tried to protect the castle by making moat. Moat or hori desu ne, hori. So the cross section of moat will be like this. This is a castle. And this is outside and it has moat dug around the castle. And this is a cross section. And there are two types of moats, dry moats and wet moats. Dry moats is just a ditch, but the wet moats would put some water in there. So it's very hard to go across and attack. And nowadays, when they became a site in, well, it's not, they're not castle anymore. They're not in function anymore. But, and maybe sometimes buried like that. And some archaeologists would excavate, try to investigate about the castle and find out the moat underneath. And in order to decide which moat it was, wet or dry, they would take samples from the bottom soil of the moat and try to find the diatoms. You see? Wait a minute. Right. Okay. Then if he finds something like these from the bottom of the moat, then it was the water, wet moat, wet type. And if they find this type, then it was a dry one, you know. So it's pretty obvious. So in order to know about the water environment of the area, you will try to use the diatom. You try to look for the diatom from the soil samples, right? So many elements that you can use and analyze. Well, these are done under the microscope. So, and they all have specialists of their field. So we always ask scientists to find these diatoms and pollens and ask for reports. Okay. And these, so those pollen and opal and diatoms would be good for reconstruction of paleo environment. Paleo environment. 古環境、古い環境と言います。Paleo environment. That would suggest the climate, flora, water environment, and so on of that time. It's really, really good. And also soil itself would tell you so many things too. In the case of Japan, most of the soil that you see under the ground consists mainly of the volcanic ash. Japan is a volcanic country, you know. It's been so much long history of volcanic activities and so much volcanic events that took place. And right. This is a cross section of the ground that we are living today. This is the ground level right here. And you have a strange things, strange layers here. These are artificial layers. Actually, this is ICU campus right next to Hong Kong. And we dug the area last year. And these top layer, about 70 centimeters deep, these are the fill, huge amount of fill made by the company called Nakajima, who developed these fighters for the warfare. 中島飛行機がね、盛り土をした70センチ。In order to pull out the plane that they built from the they have this factory, they have this laboratory in Hong Kong, and they have this factory in the west area, which is a forest now. But, and they built the plane and tried to test it, and they pulled it out and brought it down to the Chofu Hikojo Chofu runway. Quite a distance, but this area used to be farmland before the war. So the surface was very soft. I mean, this was actually the surface at the time. And these are the cultivation soil, and pretty soft. And you can't just move the airplane, heavy airplane over the soft soil. So they had to make this consolidated road just to move the plane around. So they made this fill, and these fill are so hard as stone. Anyway, so these are artificial, but this is original ground level of that time, I mean, before the war. And these natural sediments below, and yellowish ones are called loam, which are almost 100% ash, volcanic ash. And these brown, oh, sorry, wow, what happened? These brownish soil up in the upper part, these are also volcanic ash, but other elements are mixed, like organic material, you know, fallen leaves, dead trees, dead animal, whatever. And all those organic elements that contains a lot of carbon that shows the soil in a darker color. But the carbon would decay in time, in a long time. So it would, the color would be lighter and lighter as you go down. So any layer used to look like this, you know, when it was fresh. Anyway, so you see a huge, thick accumulation of loam. And this is a hole about 4.5 meters deep. And this lower level, this is a floor. And this used to be the ground level about 40,000 years ago. That was about the time the first human beings came into Japanese archipelago. And so you will find a lot of remains of human activities, human living in those layers, you know, all through the loam layers. And also, since they are volcanic ash and result of uncountable eruption, uncountable volcanic activities, so by analyzing each minute layers of the soil, I mean loam, you would be able to find out which mountain, which volcano gave this ash in what kind of event or what year, you know. the geologists specialized in volcano, they would all know all that data now. So they have this chronology of Earth, chronology of volcanic ash now, almost established. So we would know which layer would belong to which year, like this lighter area. This is the bottom of this lighter area, right there. Right there is something like 29,000 years BC. I mean, before present, isn't it? Something like that. So the soil analysis also gives you a lot of data, especially the date, isn't it? Almost absolute date too. And they can tell the difference because all the ash, not only ash, fly from the volcano. The volcanic ash always includes something like glasses, particle of tiny glasses, and something called scoria. Scoria is a mineral, type of mineral that has a construction resembles to sponge. It has a lot of airs inside, holes inside. And karuishi, like pumice, karuishi is a part of a scoria, a group of scoria. And these are all tiny particles and so light that flies around with the volcanic ash and accumulate in various parts of the island. But every event of every volcano would give different forms and different types of these glasses and scorias, as you can see. This is 80. 80 is Aira Tanzawa glass. Aira volcano is the one I just mentioned 29,000 years ago. And it was one of the largest volcanic eruption that took place in Japanese history. And it's in the Kagoshima, so it's the south end of the archipelago, but its volcanic ash flew all the way up to Hokkaido, northern island. So practically they covered the entire Japan. It was a huge, huge eruption. I will talk about that later. But this is a particular form of the Aira eruption glass. And Yuji is another volcano that gives totally different form of the glass. You can see it obviously different. And scoria too. AS is Asama. Asama is located in northern Kanto, Gunma prefecture. And FHO is a Fuji-san, Mount Fuji. And HO stands for Hoei. Hoei is a period name in Edo period. And this eruption was the final eruption of the Mount Fuji in Edo period, about 300 years ago. And you can see totally, the scorias are totally different. By looks, you can obviously tell the difference. So if you take the soil sample and look for those scorias and glasses, then you would immediately know which volcanic events they belong to. You see? By the way, Mount Fuji normally erupts in cycle like 100 to 200 years. But now she hasn't been mad for 300 years. And you know what that means. We don't know when she would get mad again. You know, be prepared. And you should stock your mask, not only for coronaviruses, but you should get more and more masks and goggles to cover your eyes, because in this Kanto, Tokyo area, the volcanic ash from Mount Fuji would hit directly. They would come flowing on the trade wind. So it will come this way. So be prepared. All right. Anyway, so you can get a lot of data from soil, especially the dating. And I have to talk about the dating system. This is, oh, wait. Forgot to show this. Distribution of volcanic ash. This is hard to see, but this is a map of Kanto area. This is Tokyo right here. And here's the F Mount Fuji right here. And its eruption would give volcanic ash flowing down to eastward. And, you know, if the area is closer, the closer you get from to the volcano, you would get more accumulation of ash. Of course, closer the thicker. And if you go as you go farther, then the accumulation will be less. So this is the map of that. You see the figures. There's a thickness of accumulation of the soil. I mean ash. And this is Ontake in Nagano, another famous volcano who would bigger eruption would give so much ash flowing. And Haruna, Akagi, Mount Haruna, Akagi, both are famous northern Kanto volcanoes like that. Well, normal volcanic eruption would give this range of the ash flowing, ash flows. But if the volcanic eruption is big enough, then it would go over the distance and may cover the entire Japan too. All right, dating, absolute dating. There are several ways of dating in absolute data. And they are all scientific methods. And especially the most popular one is called radial carbon 14 dating. 放射性炭素14年代測定法っていうんですね。And it's kind of complicated to explain about the principle, but it uses charcoal mainly or other organic material that contains carbon. And the carbon is very popular material in this universe and very stable one too. But this amount of atom amount is normally 12. Carbon 12 is a normal form. It's over 99% of the carbon is carbon 12. But in some portion, very tiny portion, they have this strange one, strange carbons that has 14 elements. And because it's not the standard ones, it's not stable. It's very easy to erode. But it takes a lot of time. It's a long time to decay. And scientist called Libby in 1950s, he found out this reduced rate of the carbon-14 as 5,730 years. And that means when this carbon-14 started to decay, it takes like more than 5,000 years to reduce its weight to half of it. And that was a rule he found out. So as we find any type of charcoal or anything that contains carbon and measure the reduced weight of it in a very scientific manner, then you would be able to know how many years was passed after that. So based on that principle, you are able to tell the absolute date of the charcoal or other material. See? And it's really good because in human history, we use a lot of fire. We burn this fuel, we burn the wood and produce a lot of charcoals remaining, you know. So in many cases, as you excavate a site, you will find so much charcoal fragments and give you so much hint as a dating material. And nowadays, the methods are so advanced and it's so accurate now. And even in thousands of years ago, in the Jomon time, you would measure it with error rates of like 50 years to 100 years, less than 100 years error. 誤差がね、100年以下、場合によっては50年ぐらいの誤差で、絶対年代がわかるということですね。And this is a chart that gives the results of carbon dating from various Jomon sites. And they are aligned along with the time scale. This is earliest part of Jomon, and this is the latest period of Jomon. And you see all the data aligned like this. And you see width of each data. That's the error range. The center of the band is the date that you would like to know. And these methods are very good, not only for prehistory. Wait. Oh, wow. This mouse, Apple mouse is terrible. Okay. And they could be used for historic time too. And this is called Shroud of Turin. トリノの聖骸って日本語で言うんですけどね。トリノ、イタリアのトリノね。Italian city, Turin, is a very traditional historic temple, Christian temple. I mean, church of Turin. And they have this treasure, which is a Shroud of Turin. And they claim that this was cloth that covered the body of the Christ when he was crucified and died. So it shows the face of Christ. You know, it's kind of the kind of story. So if it was true, it sure is a treasure. And in the late 20th century, some of the scientists took a tiny sample of this cloth and did this carbon-14 dating. And their result was 12th century AD. You know, so that means it's a fake. So it was made in 12th century, not when the Christ was living and died. So you can clarify this kind of facts too. And other method of the absolute dating is dendrochronology. Dendrochronology はね、年輪年代測定って言いますね。年輪。Use the ear line of the tree. The cross section of a tree trunk, you will see a lot of ear line. 年輪ですね。And you use that. And for example, this is a modern tree that's cut, or for this case, 1984, it was cut, lumbered. And you see the line pattern like this of the modern tree. And if you have another sample of a little bit earlier stuff like Edo period, 100, 200 years ago, of the same species of tree, you would have this sample and you compare the line patterns of the lines, and this area matches with the modern tree. You see, so this tree in Edo period and this modern tree was living at the same time in this period, particular period, right? And so on. You know, you look for the overlaps of other materials, earlier materials, and overlaps of the pattern. Then you would have one straight scale of yearing. 年輪のね、物差しができる。 Nowadays, if you're using one of the conifers, hinoki という conifers, you would be able to trace back to Jomon period, somewhere in Jomon period. It's a great study because you can count it. You have no error. It's 1 year, 2 year, 3 year, 4 years before. You see, there's no error. You can just precisely say that this is absolutely how many years ago. It's a super good method. But sometimes you may not be able to find all the samples throughout the history. Maybe you're lacking here, depends on the species. So, and you have to find the same species of material from every site that you would like to know the date, right? So it's not perfect, but it's really good. And just recently, they're combining this carbon-14 dating and dendrochronology. They are trying to measure the carbons inside those lines, So it's more precise now. They're trying to make it more precise and try to develop the method and refine the method now. Okay. And did I write this? Pine, if you use a pine tree, you can trace back to 4,500 years. And if it's cypress, then 912 BC. Cedar, 1313 BC, something like that. And it should be earlier, even earlier today. They're finding more and more species and samples. Also, another method is called obsidian hydration. Obsidian is a volcanic glass. And glass looks pretty smooth and hard on the surface, but glass has a very strange characteristics that it accumulates, it sucks water from the surface, very slowly though. And so if you can make a cross-section of obsidian or glassy material and measure the thickness of the water that came in, then you will be able to know how long this surface was exposed. That's obsidian hydration. Hydration means water. And but this depends on the hydration rate, depends on the temperature and the humidity, of course, of that area, particular site. So you always have to have a comparison samples and bury it in that site and measure the temperature and humid for like 1 year or 2. So it's not very useful unless you have tons of obsidian artifacts from the site. Okay, so there are many ways of absolute dating. Not too many though. There are so many others, but those are not very, very credible. Those are not very accurate. So nowadays we're not using those other methods. The most popular one is radiocarbon dating. But anyway, as I mentioned in the DNA explanation, no method is perfect. The methods are very good, very refined and developed now, but they're not perfect yet. Every scientific methods and technology are not perfect. They still have a range that they should develop further. They should be better in the future. So it's okay to use scientific data. Of course, we are welcome to use those data. So good to know about those minute things. But you have to be careful when you use it, when you try to explain it and reconstruct the history. Then you should be really, really careful about using those data. Okay? So at this point, those wonderful methods of dating, absolute dating, should be the reference data. You can take it as a reference, not the final answer. Okay. well, in other analysis too, you really have to really be careful. And there are so many other material analysis of various manner, like ultraviolet, 紫外線, and infrared rays, 赤外線, would be useful for detecting ink. Traditionally, we use ink, 墨ですね, ink for writing characters, writing letters, and so on with a brush. But for example, they would write something with brush and ink to the pottery, like bottom base of the ceramics. But once they were buried underground in the soil, those are organic material too. There's ink, organic too, so they're apt to decay, and character would disappear. But even though it's invisible, the minute carbon particle still remains there. So in order to reconstruct and see the original character, you use a infrared ray, 赤外線ですね. Then you would see obviously the original form of the character. It's really useful too. And X-ray, of course, you can see through the material. And also X-ray fluorescence spectrometry. It's very hard to pronounce. X-ray fluorescence spectrometry. これは日本語で、蛍光 X 線と言いますね。蛍光灯の蛍光ですね。蛍光 X 線。It's a special kind of ray that will give you an idea of the elements of a material, especially the obsidian and glass material and metal. And you would be able to tell the assemblage, 組成ですね。何と何でできているか。assemblage of the material too. And especially in the case of obsidian, there are limited sources of obsidian in Japanese archipelago. We don't find obsidian everywhere. It's pretty limited. And each source would give different assemblage of the elements. And you cannot see that. You cannot classify those just by looking at the obsidian itself, but by using X-ray fluorescence spectrometry, you will be able to, clearly you will be able to classify these obsidian to each source. And oh, it's time past 1. Okay, all right. Okay, let's take a break and I will keep explaining about these two. All right, it's 4:25, so let's take 10 minutes break and we'll start from 4:35, okay? All right.